different set of parameters that was taken. Similarly, for gas, cumulative oil, gas oil ratio, and how it is changed for all the parameters. Now, the important thing come under the objective functions, where in the proxy analysis, we can click on any of the parameter, any of the result which we wanted to see, like the cumulative oil. And if we go to this Sobol analysis tab, here different effects are there and different results are there. If we go to Sobol analysis, we can see that the permeability in the horizontal direction, it has maximum effect on the result. Means it is most sensitive, and any error, like any slight error in the permeability in the horizontal direction which we give in the our model, which will create much more error in the result. Similarly, like fracture permeability is at 94, less permeability in horizontal direction. And similarly, for all the parameters which we have varied, we were able to see which parameter is having how much effect and which is more sensitive. So, like the next step, which is the history matching, what we can do, we can exclude the variation in these like 6 of the parameters or last 4 parameters, so that our history matching can now become much more easier, and it will take much less time. Okay, so this is the main benefit of using sensitivity analysis before history matching. Now, other thing which like we can see, we have done around 66 simulation runs. And if you want to see the entire table of that run, we can go to this under control section, we can go to experiment table. And we can see, like for experiment 0, which was the base file, these were the values of compressibility, fracture half length, fracture radius, structure layer permeability, and other things. And these are the different results which were found for each of the experiment. So we can see that for all these tables, all these set of data, are the actual data that has been taken. Now, if we were not using this CMOS, what other way was there which was used earlier? Like for the database set, we have selected these values. What we had to do, we have to create a copy of that data set, open that new data set in the builder, and then specify each of these values for data set 2, which is here the second experiment. And then that base data set, open that in builder, change the parameters, and then run that. So that copy pasting of that base data set and changing the values of the parameters, this process will again, like you can say, for the 66 of those models, it will take around you can say 1 hour approx, because we have to change this data, and not just 1 hour. Like if we say that we might complete this manually for one set, if we take 5 minutes, then obviously it will go to like 6 hours of time to create all these, just to create these models, and then simulation run of those all models will take another half an hour or 1 hour. But this using this automated tool, which is CMOS, we were able to complete this entire work in just half an hour. So that is the, you can say, a very good thing about this automated tool. And here we have done only 66, like we were able to find the sensitivity of each parameter by only 66 of the experiments for this particular example. But if the parameters were more, and if the model was more like a much bigger, and if the variation was also bigger, it will take much more time. Similarly, like next I will show you in the history match. History match usually it cannot be like the best estimate, might not, you might not able to find the best estimate just by doing 100 of simulation. You might even need 200 or 300 simulation runs, 300 models need to be made to find the best match of the data. And to make all those 300 or 200 models, it will take more than a day. And more than a day is like this model is very small. That is why it will take more than like around 1 day. But for a bigger model, it might even take weeks. So that is why this CMOS is very helpful. And now, like after it has been introduced, like many people are preferring to use this kind of uh, automated tool. So up to this, anybody have any confusion which they want to ask? Okay, so after doing this sensitivity analysis, let me just also show you the file that are being created. So the files that are created is in this practical file folder, which is practical file, our entire study file, and in which the first study is CMOS sensitivity analysis. So all these files you can see are being created for each and every uh, you can say a model. Like here you can see total 26 models are created, and only top 5 or top 6 of those models, the result are kept for all the models, but only 5 or 6, the best one, are saved for the as dat file also. So before that, let me just show you here. Yeah, let me just open in here this notepad, or then this note. Okay, so this on the left side, which you can see, was our base file, and this file, the file which I have opened on the right side, is the common dataset file, which was used for the which was created by the CMOS. Here you can see, like, let me just show you. Mm, yeah, so here you can see that the permeability is constant 0.6, permeability in J direction 0.4, permeability in I direction 0.24, and permeability, the porosity 0.1. These has been replaced by this kind of, uh, you can say, syntax. Like, and this was done automatically, and this is like created when we imported and we created the parameters using the CMOS using the builder CMOS dataset creator. So here you can see like this this point one is replaced by uh, this highlighted part, and for all the similar kinds of like similar uh, parameters, other parameters, the same kind of syntax is rewritten, and this, like, if we do not have used, if we would have not used the builder, this thing has to be done manually. Like instead of 0.1, we have to write this entire code. But you can see like this is much more uh, difficult and much more not difficult, but not easier to remember, and you might make some like syntax error. So that is why it is preferred to use the builder. And like if I just close this and show you one of the file that was created, like the second one. So now you can see when the CMOS was doing, when it was like assigning the different values, and this CMOS automatically writes this entire, like it will see like like the probability in the h direction, what value has to be given. So it will replace this syntax with that value, or like for this experiment it was 0.1, and similarly it creates the data set that can be easily run in the IMAX or any other simulator. Like creating this manually, the CMOS creates it, and it makes the job of the simulation engineer very much easier. Okay, so for next step, that is the history matching, we will create another study. So create another study, like we can use this new study and again import that base data file, and again like we might have to create the set of parameters and do initial analysis again. But instead of doing that, what we can do, we can simply right click on the sensitivity analysis and click on copy to new study and rename this as, let's say, history matching, and copy and rename CMM, that is the master dataset file for the CMOS, and click on OK. So now this history matching, we can double click on this or go to history matching tab. Now, because we have copied the previous study, this will automatically contain all the parameters which was there, and it will also contain all the like initial 66 runs which was there, 66 runs, and the result of those runs, that has been done. But if we would have selected a new study, we would have to again create the parameters and again go and do the initial set of experiments. But now we already have the data of 66 experiments that can be reused. So to do the history matching, what the general property step will be the same, like it has already been done. But if we have not done, it will be same. For fundamental data, we can again we can add a different you can say parameter which we want to see. In parameters also, what we can do, we can unselect the lowest six most like the least sensitive parameters if we want. So let's go to the sensitivity analysis and check the least fracture layer of KRGCL, NG, and NO. I can unselect in this. So by unselecting this, for this history matching study, these parameters will not be tested, and it will not be used. And also if we want to, we can again edit this data file and add another parameter, but like that won't be much necessary. And next important change that we need to do is in the objective function, where we have to go to this history match quality. Now in history match quality, we have to add certain parameters that will be tested for history match error. So for that, we will select, and it shows that okay, some assignment need to be reprocessed because we are changing the objective function. So we will click OK and we will change that. So first history match error is in terms of the cumulative oil error, and for this error we will select the data from wells and we will select the cumulative oil. We will also include the error of the gas and select the cumulative gas in that for this cumulative gas error. And third, we will also add the gas oil ratio. Okay. So by adding these, we are saying that the global error, that is the global history match error, which name you can see here, oil, error in the cumulative gas, and error in the gas oil ratio. And what is the error in the cumulative oil? That is the difference between the result which is obtained for the cumulative oil minus the result of the history matching from the field history file, because that is the actual result. And if we had some more like history match data, we can also incorporate that here also. Like we can also add the, let's say, pressure error. And if we select the pressure error, we can specify that for this pressure error, the value will be taken as that well bottom hole pressure. So similarly, like we can add other also, like let's say we have two wells and we want to minimize the total sum of the pressure from those two wells. So we can add, click on insert and then select the second well from this option and select the property. So for each and every property from each well, or if we want to exclude any particular well, we can exclude that also. So these like data, these parameters, or you can say these error functions are created. So let me just delete this one. Okay, and here you can also see that we have the weight term here, and weight term means that each of these parameters, these error functions have equal weightage to the total error. We can also increase or decrease, like we can set this as 10 and we can set this as let's say 5. So if we do that, then the more weightage will be given to that, and the total error function will be created based on this weight term. Okay. So this was for the objective function, and after specifying the objective function, we again have to go to the engine setting, and here because we have selected the, we have copied the data, we have, or you can say copied the study from the sensitivity analysis. Now we have to change this to history matching, and in history matching we have different you can say ways of searching for the parameters, like the random brute force and differential evaluation, partial particle swarm evaluation, and CMG itself has their you can say in-house optimizer, that is a DECE, and and it is very fast in comparison to these other engines or other algorithms. So we will select this CMG DECE, and we will specify how many runs of how, or you can say how many experiments we want to do, or you can say how many set of parameters we need to check. So here we can minimize also and increase also. So like you can see by default it's saying 500, and usually like 200 or 300 sets of data are tested. Okay, why are we defining the errors? Okay, see, we are defining the error. Okay, let me show you this curve. Okay, in the sensitivity analysis, I think the curve was there. Okay, Amir, you can see this curve, like this black line shows the base, the result of the base file, and this blue dot shows the, you can say the data from the field history file. Okay, so you can see that there is some error between these two, and we are saying that we need to minimize this error. Okay, so like when we will run the simulation and we will run the simulation of all the data set, we will get different values or different curves for different set of parameters. And we want to select that parameter and obviously that can be done manually also, but in system, in the software, we can automatically feed that, okay, we want this error to be minimized and that will be selected as optimum set of parameters. So that is why we are defining this error. Like there is error in the cumulative oil, there is error in the cumulative gas also, there is error in the gas oil ratio also. So all these errors between the result of the simulation and the actual result from the field, these has to be minimized. Okay, so that is why we are defining the errors. Is the part is the first question, the answer for the first question clear to you, Amir? Okay, so the second is that you are asking why the weight term. See, weight terms is like if we want, we can give more importance to the cumulative oil and not is at that importance to the cumulative gas. Let's say in this, if I say that this is one, and if I say that the cumulative oil error is given a weightage of let's say 15. So what function we can see is that the global of error of the cumulative oil plus one times the error in pressure plus one times error in cumulative gas and one times error in gas oil. So we are giving more weightage to cumulative oil, and what this will do is that like you can say it is given more weightage, and because it is given more weightage, so the error will be very less. The final error will be very less for the cumulative oil error. Okay, so that is why weightage is given to this particular term. And usually, we can give, usually we give equal weightage to the cumulative oil, and we give different set of weightage for the pressure, and that thing is also done. Why cumulative gas? Because we can see that cumulative gas is also a term where we can see very huge uh, you can say error between the produced and the simulated result. Okay, so let me just keep these all errors as one, and we can also remove this pressure error because we can have seen that the pressure is very much same, and it will only improve and reduce the increase the amount of time. So we can remove engines, or you can say different type of algorithms for searching the the optimum set of parameters that has to be taken. And usually what is done is I have given 500 set of experiment, but the 500 set of parameters are not automatically selected at the first stage. What is done is 45 or 50 set of parameters are created. They are tested, and whichever parameter set of parameter is giving least error, next 50 or 30 set of parameters are taken or selected based on that parameter. So the optimization or the error starts to reduce. This I will show again, when the result will go on. And here 500, let's keep that 500. And here I have to select that the global error has to be minimized, not maximized. And next we have to go to the experiment table. And again, we have to reprocess this because we have created some error functions which was not calculated during the sensitivity analysis, but because we have already simulated those results, we won't be again simulating, will be only calculating the result for the values of the error function only for these 66 sets of set of parameters. So we can go and reprocess all experiments. By reprocessing, we have found, okay, after reprocessing, I can show you. Okay, so after reprocessing, we have got that for these 66 set of experiments, we have these different values of the cumulative gas for the cumulative oil, and this is very close to, you can say, this red line shows that it is very close to the field history file, and it is having least error. But we will go and do some more simulations so that this can be like much better solution can be found. So we will go to engine setting, and here again, like in simulation setting, we can change the value of concurrent jobs that will be run depending upon the processing power of your computers. And go on control center and click the start button. And then again, okay. So here you can see that for those 66 of the data, the global history error was calculated just by reprocessing those experiments. But if we would have not copy pasted the sensitivity analysis and created a new uh, study, what it would have done, it would have started from this initial stage of the, or you can say the initial experiment would have been again done, and then based on that, the result would proceed and the set of data will be created. And if you want to see the set of parameters that are being taken, we can go to this experiments table and we can see all the data. You can see up to like this after 66, these three new parameters are created. So these new three sets of parameters will be tested, and then again a new set of parameters will be tested. Up to total 500 experiments are done. Okay, so yeah, in control center. So instead of running this, I have already done a similar kind of done this tutorial previously, and I am going to show you that. So I'm just stopping this for the moment, and I will open that another history matched result. So I can go to the start page, tutorial file. So this is the another more another project which is having the same data, but I have completed the history matching. And in this, if we go to control center, you can see I have done around 200 of experiments, or I guess 164 or 163. And you can see that initially, like if you see this part, initial 66 of the experiments, the global error was in the range of 0 to 80%, and that was from the sensitivity analysis. And after that, all the experiments, which all the parameters which was taken, they had very less global error, and that is further reducing with when the new set of parameters are being created. So here we can see that this that is 135th of the of the experiment, or the 135th set is having the least error of just 2.53%. And in time series also, if we go and see the cumulative oil, you can see that it is very perfectly matching to the history matched blue dots. Similarly for the cumulative oil, cumulative gas, and gas oil ratio. So this these around 160 of the experiments took around 6 hours to run, but this was a very simple model, and usually like for a very large model, if you go to do up to like 500 or even 200, it can take like weeks of time to just create the model and just run those models. So this automated history matching tool just is a tool of like automation, and it reduces the workload of humans. And obviously, but the simulation run for each of those model will again take time. So instead of 6 hours, it might have taken 1 week for just creating the model and then running it. So now after so this tutorial related to the history matching is also complete. And see, these initial 66 set of the parameters that is taken, that contains the values of the parameters that was used in the sensitivity analysis. Okay, and at that time we were not aiming to reduce any global error because we have not specified any global error. Okay, so this initial set was only to see the sensitivity of each parameter. But and that is why these have a very huge error, and it only tested the what is the sensitivity. But after these experiments, like after 66 and 67, the our aim of the of selection of values for the parameters was to reduce the error. So that is why the next set of parameters that was selected, it has less error. Like if I show you this experiments table, the first 66 of these experiments have the values that are just randomly created, like for by using the RSM methodology, the which we have selected in the sensitivity analysis. But after these 66 of the data, and these 66 or 65 of the models, the next parameters, the next values of the parameters that have been taken based on the parameter that is having the least error. So that is why after it is like continuously, if it is running, the continuously the values of parameters are selected, it's having less and less error for each experiment. And like if I only, like say if I only would have done up to 100, maybe this 88 would have the least of the error. And then after, if we have not done a further experiment, the this will be selected as the best, or the, you can say, best model or the history match model. So, and if we increase the number of experiments, it will again this, even like the which we are getting at this point, like up to 20% error. Maybe if we select 500, or if we do 500 set of experiments, the last 100 of those will have even like only 10% error maximum. Okay, so that is why there is an abrupt change, because initially our aim was different, and now for these sets of experiment our aim was different. I think I can show you one more. This was done. Okay, here also, like in this study which I did for another project of mine, like you can see, like initially actually I did not did any sensitivity analysis. I directly went for the history matching, and initial like 27 or 28 of the data set have very huge error. But after that, when the next 20 or 10 values of the parameters were selected, it was selected such that the history matching continuously reduces for each of the each of the data sets. Okay, so that goes on in reducing it, goes on reducing the error for the next data set that is, or for the next set of parameters that is being created. So let me just again. Yeah. Okay, so like this one idea, you can say giving the best history matching and the least error. So we all that error or that the set of say that the set of parameter will be the experiment number 135. So we can go to our this what we can say this folder. Refresh this, go to history match and select this one. Okay, this was for this current one. So this 135, that is the history matching 135.dat. Now this model I can now use to do the future prediction. And what I will do, I will just copy paste this to another folder and maybe run one more time and then use the history, like then change the dates and then like add several dates and see how the production in the next 1 year will go and change different parameters like the pressure and the flow rate and see how that will affect the production in our production and the pressure in the next 1 year or 2 year, and that can be used for the prediction. So this is the like after history matching, that is the only thing that need to be done. Okay, so up to this, anybody have any confusion? And this is the first slide. Okay, see, what is happening during history match is that, see, okay, let me just open a whiteboard, that would be much easier. Okay, see, what is happening in history matching is that we are testing the different values of different parameters. So let's say like we have different parameters such as we have porosity, we have permeability, we have the permeability of the fracture, and for any model, like in general, I'm saying what is going on in history matching, and we have let's say the connate water saturation and all other parameters. And due to these parameters, what is happening is we are getting some result, like we are getting let's say oil production as this, but by from the history from the you can say from the data which we collected from the field, we got that we are getting the oil produced as this curve. Okay, so this means that this the result which is we are getting from the model, it is not correct, or you can say the model itself is not representing the reservoir. So what we have to do, we have to change the values of these specific parameters. So let's say we have given this as 0. 0.2, this as 200 millirc, 200 millirc, and this we have given as 2 darcy, this we have given as 0. 0.2. So this initial set of experiment gave this data. Now in history matching, what we have to do, we have to select some other values of these parameters so that we get very close to the actual result. Now, previously what was done, this selection of these values, like we are thinking that maybe this is not 0 0.2, this is 0 0.3, this is let's say 212, or this. Instead of selecting this manually, which parameters have to be selected so that we find a better result, what is done is we are specifying a lower and upper range in the for these parameters in the CMOS. And okay, so we will simply tell the CMOS that vary the values of the porosity from 0.1 to 0.4. I'm just giving some random examples, and vary this from let's say 100 to 500, vary this from 1 to 5, and find the exact parameters or set of parameters that will give the best result. So this part, like finding the values for the parameters that will give the best result, is done by CMOS automatically. And how it is doing, it is just varying all the parameters and checking all the for this only, first we do the sensitivity analysis, like which parameter is having the most effect in the result and which is having the least effect in the result. And then the CMOS creates all the data sets, and we get the you can say that curve which is closely very close to the history match file and which is having the least error. Okay, so okay, see, let's say one set of the parameters is 0.3, 212, 2.5. Okay, so for this, let's say for this we are getting 50% error. Okay, so for this we are getting let's say 40% error. Okay, so this is if we are getting some error, that means that this set of parameters are not the parameters that should be used for the model. Okay, and we want to find the set of parameters that is giving, uh, depending upon the simulation engineer, let's say less than 5% of error, or 5% or 3%, or whichever other set of parameters giving the least error. Okay, so that parameter has to be selected. Whichever set of parameter will give the least error, that will be selected as the best model for the reservoir, or the history matched model of the reservoir. Okay, that is the importance of error. Okay, so any other questions which you want to ask regarding history matching or sensitivity analysis? Okay, so if there are no questions, I think we can end this session. Okay, so goodbye and have a nice day.